Welcome back to module 9 of object oriented analysis and design. We have been discussing about elements of object model. Last module had discussed about abstraction and encapsulation, and in the earlier part of this module we have talked about modularity and different aspects of what a modularity should try to achieve and what are the basic principles of intelligent modularization. Next, we take up the last of the 4 major elements, that of hierarchy. Hierarchy is a ranking or ordering of abstractions. So, you would have seen a glimpse of this in module 8 when we talked about abstractions, and we said that abstractions could be hierarchical as well. So, you got initiated to that, but hierarchy by its own requirement is eligible to be another important element for object models and is described as such. So, it is a ranking of abstractions. So, which mean that the different abstractions that the system has, that goes from details to less details to even less details to absolutely top level. So, it is kind of in a artistic view, it will give you a pyramid like structure to work with. So, if you are at the top of the pyramid, then you get to see only very simple the whole thing in very simple terms. You use the abstractions only at that level. Then as you go down, you see more details, as you go down you see further details, and different kinds of hierarchies play a role, and let us take a look into those. What we are talking about here, again you have already had some glimpses of it when we talked about specifically the canonical form of complex systems. We exposed you to 2 orthogonal hierarchies that are common, most important for complex system: the hierarchy of class structures, which is typically called the abstraction hierarchy or is a hierarchy, and the hierarchy of object structure, which is called the part of or decomposition hierarchy or has a hierarchy. The class structure hierarchy shows you how over the hierarchy the common properties are shared between one layer to the next, and the object structure show you a hierarchy of containment, how one object can be thought of having been composed of different components or different component objects, and this in turn can be thought of in terms of subcomponents and so on. So, in this context the common structure and behavior are migrated to what is known as superclass. So, what we say is in a hierarchy, a class that occurs higher in the hierarchy. Hierarchies are typically drawn in terms of inverted trees. So, the classes or the abstractions which occur at a higher level in that tree are known as superclass, and the related lower level abstraction is called a subclass. So, if we look into the diagram below, this is we say is the root abstraction. So, that this root, a system is being defined in terms of one single concept, vehicle. So, if we say a vehicle, all of us understand something. So, there could be lot of different, as we say, specialization, but vehicle we can say is combines all of them together by one unified concept, that it is a mechanized gadget to transport. A vehicle is a mechanized gadget to transport. Therefore, if this is the general concept, then we can always say that vehicles at least can be of 3 types, that which transports on land, the land vehicles, which transports over water, water vehicles, and which transports through air, air vehicles. There could be other kinds of vehicles also, like vehicles going through space, vehicles which can go over more than one medium and so on. We will not go to those kind of complexity, but when we say this, this is what is the concept hierarchy or abstraction hierarchy. So, this is what we say is the superclass, and let me use a different color. These are the subclasses. Now, please understand that superclass and subclass are relative notions. So, vehicle is a superclass relative to land, water or air vehicle. But if I just focus specifically on the water vehicles, let me pick up red again. If I specifically focus on the water vehicles, then the ships, the boats, they are subclasses of this water vehicle. So, this now becomes a superclass, this is a subclass. So, it is in the hierarchy, if two concepts are related in terms of generalization and specialization, then we will use the term superclass for more abstract or more generalized concept or abstraction, and we will use subclass to represent specialized, more specific class or more specific abstraction. Now, as we go over this hierarchy, then on two sides there are two directions showing that certainly if you go from below to lower level to higher level, then you are actually generalizing, that you are losing spatial properties. So, as you go from car to land, you lose the property that car is for limited transportation of limited number of people or limited volume of goods, whereas bus necessarily is for transportation of large number of people. All that the commonality that you can out here as you go up is both of them run on land. And similarly, you have certain commonality with water, and when you go to vehicle, you lose even more, you lose even the fact that on which medium the vehicle transports, you just retain the generalization that the vehicle indeed transports. So, this is what would keep on happening. So, when we go the other way, that is when we go from generalization to specialization, then a subclass can add, modify or hide methods from the superclass. So, vehicle says that I can transport. When I come to water vehicles, then it will add that I can transport, of course, I have got that from the superclass vehicle, but we will add that I can float. This is not a requirement of vehicles in general, but water vehicles will have a requirement to float. I will add different other factors, like I can possibly go with much less loss of power, because water provides far less resistance than land. So, I have more and more properties coming in here, and then when we go further down, then ship has everything that water does, water vehicle has, but it has something more. It says that it is a big water vehicle, which is typically motorized and so on. Whereas, when I talk about boat, then I will typically have water vehicles which are manually driven, where they will have oars and all that. Ships will usually, at least these days, will never have oars. They are driven by underwater propellers and so on. So, as we go along the specialization from top to bottom, we can add and modify different methods. In fact, there could be instances where we may need to hide a method. For example, I will just by the side show you an example. Suppose I am talking about a concept bird. So, I can say that crow is a bird, because anything the bird can do, crow can do that. Crow maybe crow can do something more. For example, crow can create a kind of sound in a certain way. I may have eagle is a bird. It can do anything that the bird can, but it can do something more. It can go to really very high heights. But let us now look at that. I want to put here, say, ostrich. All of us know ostrich is a bird. We know it is a bird, but we also know that a method or a property of being a bird is to be able to fly. Ostrich, we know, cannot fly. So, we get into certain kind of contradiction, that our hierarchy rules say that a subclass will get all the methods, it can add new methods, it can change certain methods, but it will get all the methods that the superclass has. The superclass has a method called fly. Birds can fly, crow inherits that, crow gets that, crow can fly, eagle gets that, eagle can fly, eagle can add other method that it can glide, which crow cannot. But I come to ostrich, it cannot fly. So, this is a specific example to show that on a hierarchy you may often need not only to add new properties to specialize, not only to maybe change the way the method works, change the way the birds fly, change the way the birds reproduce and so on, but you may need to actually omit certain methods which a superclass has. So, you need to look at all of add, modify and hide methods from superclasses. So, hierarchy basically provides data abstraction, and a hierarchy provides on top of the data abstraction, it tries to provide a mechanism by which the properties can propagate from one layer to the other. Now, you can see that once we have done abstraction, so we have already done three major elements. So, we know that there is abstraction. So, I have abstracted a concept. Then we know on that abstraction we have put an encapsulation. So, moment we have put an encapsulation, we have put an opaque barrier to hide the methods and the state. We said implementation is not feasible, because it is encapsulated. Now, I want to say that now I am coming and saying that here I have vehicle, it can transport, and then I have land vehicle, then I have car and so on. Now, if I have done my abstraction and encapsulation in the right way, then this is encapsulated. The properties of vehicle are encapsulated. Then how does land vehicle define how transport happens? Because vehicle in general cannot say how transport will happen, it is just an abstract concept of transportation. Land vehicle has to do transportation using certain physical laws. All vehicles need to do transportation using certain physical laws. Land vehicles use friction or the absence of friction or gravity and all that. Water vehicles use buoyancy and third law, etc. Now, so there is an inherent contradiction in terms of the way we abstract and encapsulate, and when we want to create hierarchies where we want properties, methods to propagate from a superclass to the subclass. Now, this is something which is specifically handled in different ways by different implementation languages, different programming languages. And particularly one of the reasons that C++ or Java gets very popular in terms of object oriented programming is the fact that these languages allow you great flexibility to provide mechanisms by which you can honor the abstraction and encapsulation, at the same time create hierarchies. So, though we are not going to discuss in depth about the language constructs in this course, but it will be good to understand that there are concepts like visibility, which say that you can of your encapsulation, you can create different grades of encapsulation, different porosity of encapsulation. Certain encapsulations are known as private, which are totally encapsulated. Only if you are inside that class, only if you are inside that abstraction, you will be able to use those properties, use those methods. And the other extreme is basically to provide the exposing part of the encapsulation to honor the contractual interfaces that you wanted to provide, which is the public parts, the public visibility, which anybody and everybody can have a look at. Now, these two do not solve your hierarchy problems. So, C++, Java, these kind of languages introduce a very interesting kind of intermediate visibility or intermediate encapsulation granularity, where you say that your different implementation parts are protected, by which they are available to the class as the private ones are, as the public ones are as well, but it is specifically available to, this is the main part of protected, that is available to the subclasses, but these are not available to public. So, protected parts do not become part of the contractual interface, they are just an extension of the implementation of the structure, but they can be propagated along the hierarchy to make the realization of hierarchies possible. So, here kind of I am little bit started migrating between the conceptual aspects of object oriented analysis and design, and slowly taking you closer to how will it look in the implementation. So, I just included this part to be discussed as a part of hierarchy to give you a glimpse that it is not that everything in this whole paradigm of things are fits into together exactly seamlessly. Certain concepts which we need to impose, like hierarchy, which is very critical to manage complexity, contradicts some of the other assumptions we made for abstraction and encapsulation. But this is just to highlight that do not get worried, because the languages, when you finally come to system implementation, the languages will be able to take care of that. And we will see when we talk about UML, that when we translate all these different elements of object models into UML language, we will be able to express this varied kind of visibility and porosity of encapsulation over the UML hierarchies. Now, in terms of this, these are more like terms that you need to understand and remember. On a hierarchy, we say the term single inheritance is referred to when there is one superclass and there is a specialized subclass. So, we will say here in single inheritance, we will say there is a single superclass, and this the above one we will write it as B is a. So, that is the simple representation. So, that is called a single inheritance, and if we just refer to the hydroponic gardening system, then fruit growing plant is a growing plant, grain growing plant is a growing plant. So, these are all specializations, and these are specializations, and these are generalizations, and growing plant may be the most general superclass that it will have. Single inheritance can also be extended in multiple levels. So, here we have the same, we have B is a and then we have C is a B. We have already seen instances of this in terms of the vehicle example. So, when this happens, then we say it is multi-level inheritance, that is inheritance is happening not between just two levels, but it is more than two levels. So, a manager is a lead, LMS, the leave management system, a manager is a lead, can do anything that the lead can do. Lead is an executive, the same properties behave, executive is an employee. So, employee happens to be the most generalized superclass and manager happens to be the most specialized subclass in the whole hierarchy of multi-level inheritance. A different concept come in terms of multiple inheritance. In multiple inheritance, you basically have more than one superclasses which is jointly specialized into common subclass. So, whenever that happens, we say that we have multiple inheritance, because when this will happen, then C, the class C will enjoy the properties methods of class A and as well as of class B. And multiple inheritance is a regular reality of our life. Multiple inheritance come from the different roles that we keep on playing all the time. For example, let's think about I have been regularly, I am getting regularly assisted in this course by 3 teaching assistants, TAs, Himadri, Srijoni and Tonni. So, think about the classes of students and teachers and TAs. So, what will happen? We will have students. What is a distinguishing property of a student? Why is it a key abstraction? Because students study. We have teachers. What is a distinguishing characteristics of teachers? They should also study, but distinguishing characteristic is they teach. What is a TA? A TA has to teach because she is a teaching assistant, but to be a teaching assistant you need to be a student. So, a teaching assistant, a TA is kind of specializes from, it gets certain attributes, certain properties from the student, certain properties from the teacher. And so, this is one very direct example of multiple inheritance you will need, and you will, if you think little bit more, you will find that you will need all different kinds of properties of, or rather power of subclass TA to add, modify and hide methods. For example, TAs can assist in the course, TAs can evaluate assignments, but TAs cannot award the final grade, which teachers can. So, if I say TA is a teacher, as I am saying here, then TA will inherit the method to be able to award grade to students, which it has to hide. So, but at the same time it will, from the student it will get a lot of properties which will possibly it will be able to enjoy altogether. So, this is the basic context of multiple inheritance. It is a I would like to warn you, there is another different example here which you can make out by yourself, but I would like to warn you, multiple inheritance is one of the very difficult areas of design, because it is not only easy to identify multiple inheritance, there are a lot of fundamental theoretical conceptual issues in dealing with multiple inheritance. Some of them relate to that if you inherit the same method, same behavior from 2 different superclasses, then how should you behave in the subclass and so on. So, there are different design principles relating to in terms of dealing with multiple inheritance, and we will talk about some of those when the time of actual UML modeling comes. The next is hierarchical inheritance, which basically is when you have more than one subclass specializing from one common superclass, which is what we have already seen quite a lot in terms of the vehicle example we just took. Here I have shown another example based on mammals. So, this is mammal is a most generalized superclass. Then we have cat, dog, horse, elephant, all different subclasses. They in turn have other subclasses. So, when we have this kind of an inheritance structure, we say we have hierarchical inheritance. Now, in reality what happens is you will not have often you will not have pure single inheritance or single multi-level inheritance or hierarchical inheritance or multiple inheritance. You will typically have a mixture of them, and therefore, often you will have a situation of hybrid inheritance, as you can see here. So, in this hybrid inheritance you can see here you have a more pure form of hierarchical inheritance. Here you have a more pure form of multiple inheritance, and if you look into this part of the structure, then you have multi-level inheritance. So, hybrid could mix up different kinds of inheritance structure in this, and the reason an object analyzer, a object oriented designer, someone equipped with that, needs to understand the hierarchies and this inheritance structure is, this is one great tool which go a long way to restrict complexity of systems. Because as you can understand that once a subclass can inherit a whole of the superclass with very minimal changes, additions, and hiding, then you have a great opportunity for reuse of code. You have great pointers towards how should you modularize. You have a great use of the whole notion of abstraction that you have been working with. So, a major consequence of hierarchy is these different forms of inheritance that it results. So, to summarize in this module, we conclude on the major elements of object models. We had 4 of them, 2 were done earlier, and here we have talked about modularity and hierarchy, 2 of the other major elements that deal with modularity. Certainly deals with the separation of concern. The better separation of concern you can do in terms of code organization, you have better modularity in implementation, and we have talked about several principles for that. And hierarchy deals with the inheritance aspect of an object, and these 2 together will go a long way supporting with abstraction and encapsulation in doing good design of object oriented systems. Now, in the next module, we will take up the minor elements which are not essential, but often turn out to be very useful elements to provide the actual related functionality of the system, that will be in module 10.